Hello everyone, I am Deepthi with registration number 251FB04001. Today I am here to present a topic called Strassen's matrix multiplication, which is based on the divide and conquer technique. Introduction. Strassen's matrix multiplication is a divide and conquer algorithm used to multiply matrices efficiently. The usual matrix multiplication method multiplies each row with each column to achieve the product matrix. This approach takes big O of n cube since it takes two loops to multiply. To reduce this computation time from big O of n cube to big O of n power 2.81, Strassen introduced a faster algorithm. Now let us see what is traditional matrix multiplication. In conventional matrix multiplication, the product matrix C is obtained by multiplying matrix A with matrix B. For matrix multiplication to be valid, the number of columns in matrix A must be equal to the number of rows in matrix B. Each element in the result matrix follows the rule row of A multiplied with column of B. For example, when multiplying two 2 by 2 matrices, we compute the elements C11, C12, C21 and C22 using direct multiplication and addition of corresponding elements. This process requires 8 multiplication operations and 4 addition operations for a 2 by 2 matrix. What is Strassen's matrix multiplication? Using Strassen's matrix multiplication, the time consumption improved a little bit. Strassen's method can be applied only to square matrices where the order of the matrix is n by n and n must be a power of 2 such as 2, 4, 8 or 16. The key observation made by Strassen was that multiplication operations are computationally more expensive than addition and subtraction operations. Therefore, by reducing the number of multiplications and increasing the number of additions and subtractions, the total computation time can be reduced. This optimization makes Strassen's algorithm an important example of how algorithmic design techniques like divide and conquer can significantly improve efficiency. Now let us discuss the core concept behind Strassen's matrix multiplication. It follows three concepts. The first one is divide and conquer approach. In this method, the large matrices A and B of size n by n are divided into four smaller submatrices of size n by 2 by n by 2. The next important idea is reducing the number of multiplications. In standard divide and conquer method, multiplying these submatrices requires 8 multiplication operations. However, Strassen shows that same result can be obtained using only 7 multiplications. Finally, the combined step. The results of these 7 multiplications are carefully added and subtracted to construct the final result matrix C. By repeatedly applying these steps recursively, Strassen's algorithm achieves better performance for large matrix sizes. Let us see how Strassen is applicable to 8 by 8 matrix. Strassen's algorithm works only when the matrix size is a power of 2. Since 8 is equal to 2 power 3, an 8 by 8 matrix is perfectly suitable for applying Strassen's algorithm. Let A and B be two 8 by 8 matrices. Our goal is to compute their product C equal to A into B. To apply Strassen's algorithm, we divide each 8 by 8 matrix into smaller submatrices. Specifically, each 8 by 8 matrix is divided into 4 4 by 4 submatrices. So, matrix A is divided as A11, A12, A21, A22, where each Aij is a 4 by 4 matrix. Similarly, matrix B is divided into B11, B12, B21 and B22, where each Bij is a 4 by 4 matrix. Now, let us consider matrix A of size 8 by 8. We represent matrix A by dividing it into 4 equal submatrices. Now, the top left block A11 is again divided into 4 equal submatrices of size 2 by 2. Likewise, the remaining 3 will also get divided. Similarly, the same process will be done for matrix B. After dividing matrices A and B into 4 4 by 4 submatrices, Strassen's algorithm does not compute 8 multiplications like the normal method. Instead, it defines only 7 intermediate products M1 to M7, which are as given below. After computing the 7 intermediate products, we now combine them using the below operations to form the final result matrix C. Now, observe the recursive nature of Strassen's algorithm. The multiplication proceeds as 8 by 8 reduces to 4 by 4, 4 by 4 reduces to 2 by 2, 2 by 2 reduces to 1 by 1. At the base level, the normal matrix multiplication is used. This recursive reduction, along with fewer multiplications at each level, makes Strassen's algorithm faster than the conventional method. Now, let us analyze the time complexity of Strassen's algorithm using the substitution method. From Strassen's algorithm, we observe two important points. First, at each step, the algorithm performs 7 recursive matrix multiplications, each of size n by 2. Second, the additions and subtractions of matrices takes order of n square time. So, the recurrence relation is written as T of n equal to 7 into T of n by 2 plus C into n square, where C is a constant. Now, we assume a solution for this recurrence. T of n is less than or equal to K into n power log 7 base 2, where K is a positive constant. Next, we substitute this assumed solution into the recurrence relation. So, we get T of n is less than or equal to 7 times K into n by 2 power log 7 base 2 plus n square. Now, we simplify the term with the exponent. N by 2 power log 7 base 2 can be written as n power log 7 base 2 by 2 power log 7 base 2. Since 2 power log 7 base 2 equals 7, this becomes n power log 7 base 2 divided by 7. Multiplying by 7 cancels the denominator, leaving k into n power log 7 base 2 plus cn square. Since n power log 7 base 2 grows faster than n square, the n square term can be ignored for larger n. Hence, by ignoring constants, the time complexity is big O of n power log 7 base 2, which is equal to big O of n power 2.81. To summarize this, Strassen's matrix multiplication is an efficient divide and conquer algorithm used to multiply two square matrices faster than the standard method. In the standard matrix multiplication, multiplying two 2 by 2 matrices requires 8 multiplications. Strassen's algorithm reduces this number to 7 multiplications by cleverly combining additions and subtractions. This reduction in the number of multiplications significantly improves performance, especially for larger matrices. Hence, Strassen's algorithm is more efficient than the conventional matrix multiplication for large-scale computations. Thank you so much.